Hello, and welcome to the fourth devlog of the World Simulation Project. For those who are new to the series, the overall plan for this project is to create a large-scoped grand strategy game, taking place on a fully procedural-generated, tile-based world, which will be very detailed and interactive. Today, I'm going to show you a camera system overhaul and the brand new map mode feature. Before we start, if you like my content or if you are interested in following the progress of this project, please consider to subscribe to this channel and leave a like or a comment. And if you want to join the discussion about it, or if you like to participate in the surveys I will start in the future, you can join my new Discord server. You will find the link in the description. What you already can see is the new cinematic camera. It seems like a feature which should be implemented when the game is already feature complete and only needs some nice-to-haves and make it feel polished. But I preferred to have it right from the beginning to take some good footage for presentation purposes, for example these devlogs. This is how it works. What you see here are the components of the main camera game object. The last of them is a new script called the camera handler. It is quite simple. Its only purpose is to hold a scriptable object which contains the camera logic and call its reset and execute method. It contains all the extra logic needed for a working camera. Having it designed this way, I can easily switch between different camera types just by exchanging these scriptable objects in the inspector. Doesn't that look nice? Imagine shots like these with a more detailed and polished world. The next big thing I wanted to have are map modes. In the first devlog, I showed you the first prototype for my game, which was completely made without any game engine. There I already had map modes, so I tried to recreate them here. As you already know, every tile contains many different values, for example how many vegetation, animals, coal or gold you can find there. Right now, the only way to see them in-game is the tile selection pop-up window. If you want to check a single tile for minor decisions or micromanagement, this is perfectly fine. But for high-level decisions for your whole civilization, it is super unhandy. These decisions need a bigger picture of the whole situation. For that, map modes would be the perfect tool. But to make them possible, I had to go through serious trouble and ask some other developers for help again. The problem was the huge count of tiles that need to be asked for the respective value to display. In an early version, whenever I want to select another map mode, I had waiting times of more than 2 seconds for a quite big world. That doesn't sound like much, but try to imagine yourself playing Civilization, and a simple mouse click causes the game to freeze for 2 seconds. You wouldn't enjoy this feature at all. A big shout out goes to Wayne Games, who helped me a lot with optimizing the process of loading all the tile values. Let me show you the basic principle behind the map mode system first. The main idea behind the map mode feature is exchanging the world material. Until now, we have one material which displays the vegetation zone according to the terrain height. This is fine for now, because the definition of the vegetation zone within the tile data follows the same rule. But for all the other values, this approach won't work anymore. Every value can be very different and independent of any rule or math. So it's not possible to create a world shader which contains this rule. Instead, I need a shader which can receive some kind of data buffer. This buffer needs to hold the respective values for every single tile. The values then need to be mapped onto the world. The first thing I thought of was a dynamic buffer, or a compute buffer. But Unity's shader graph does not support this, so I came up with another solution. A simple lookup texture where every pixel represents one tile in the world. This texture then is stretched so that one pixel covers a whole tile. At first, I collect the tile data from the ECS world. This by far is the most computationally intensive step. To maximize the performance, I use Unity's job system. You can see the code here. Just pause the video if you want to take a closer look. Again, a huge thanks to Wayne Games for the help to figure out how to set up and schedule the jobs. Next, I create the lookup texture. Like I said, every pixel holds the value of one single tile, so I iterate through all the data and set the corresponding pixel's color. The last step is to send the texture to the material and set other properties of this material, depending on the selected map mode. Finally, the prepared material is assigned to the chunk game object. To wrap up this episode, I want to give you a little teaser about what I'm working on next. This is a tool to give me a preview of the generated noise used in the world simulation project. After the map modes were completed, I saw that the generation settings of the vegetation and resources were complete nonsense. Fixing this would be super lengthy, since the world generation still is quite slow, but for this, seeing the buffer texture would be enough, so a separate tool for this would be perfect. At the same time, I'm creating a library specifically for creating noise. I will show you the progress in the next episode. So that was it for this time. Tell me about your opinion in the comments, and don't forget to like and subscribe if you want to see more. And consider joining the Discord server to get some more details earlier than everyone else. Thanks for watching, and see you next time.